All right, we are doing section 6.2, law of cosines. So the law of cosines has a basic outline. It has one side squared equal to the other two sides added together squared minus 2 times those two sides times the cosine of the angle of the side that was by itself. So if a is by itself on one side, a squared, then it would be the cosine of a in the equation. And what I did was I rearranged all these equations for you. So if you're solving for an angle, that it's a little bit easier. Otherwise, you are going to have to memorize these. So I recommend just knowing the pattern and then rearranging it yourself. Instead of memorizing all 6 of these, just memorize one pattern and rearrange. Okay, so if we have find the 3 angles on the triangle with sides 8, 14, and 19. So here's 8, 14, 19. So this would be angle B since it's across from side B. C is here across from 14, and A would be across from 8. So if I want to find, let's just go with B first, the angle. I would use the rearranged cosine of B equals 8 squared plus 14 squared minus 19 squared divided by 2 times 8 times 14. You're going to take the inverse cosine of all of that. You're going to get a negative decimal. When you do, you'll get B is 116.8 degrees. Once you get one pair, it's an oblique triangle, so once you have a pair, you can use law of sines, and it's easier, so I would recommend that. Let's say we want to find angle A next, using our pair of B's. So if I want to find angle A, I'm going to put that on top of law of sines. Sine of A over 8 equals sine of 116.8 over 19. Cross multiply, take the inverse sine, and angle A is 22.08 degrees. And then to find angle C, I can subtract the 2 angles that I know from 180. And I get 41.12 degrees. So I always have 3 knowns, and I find the 3 unknowns. Here we have a side angle side. Find the remaining angles and the side of the triangle known with sides 15, 10, and 115 for our angle. So here's our A, 10, so that'll be across from angle C, and 15, so that'll be across from angle B. Let's find the third side. And this is set up perfectly for the law of sines to find that side A because we have the angle opposite it, which is how it's going to go. That's our pattern. So if I want to find A, it'd be A squared equals the 2 other sides squared and added together minus 2 times the product of the 2 sides times cosine of 115. And you'll have to multiply and add all that together, take the square root, and you get 21.26 for A. And now that we have side A, we have a completed pair, and I would use law of sines to find the next angle. So let's do angle B. Okay, doing the inverse, you'll end up finding that angle B is about 39.75 degrees. And we need to find the last angle, which is not too bad because we can subtract from 180, the other 2 that we know. Angle C is 25.25 degrees. Okay, let's do an application with the law of cosines. We have a pitcher's mound on a women's softball field. Let me draw this picture while we're thinking about it. Okay, so the pitcher's mound is 43 feet. Let's say this is right here. 43 feet from home plate. And the distance between all the bases is 60. How far is the pitcher's mound from first base? Okay, so this is not a right angle because the pitcher's mound is farther inside. It kind of looks like a right angle from here, but it's definitely not. We do know another angle, however. We know that these are the pitchers, these are all 90 degrees between the bases, which would make this angle 45 degrees. Okay, so now I have the enclosed angle on the two sides, which is exactly how we need to set this up. So it'll be x squared equals 43 squared plus 60 squared minus 2 times 43 times 60 times cosine of my angle enclosed, which is 45 degrees. Multiply, add, all that fun stuff, take the square root, and we get 42.43 feet from first base. A ship travels 60 miles due east, that should say, 60 miles. And then adjust its course northward. So it's not going straight north, it's just changing a little bit north. After traveling 80 miles in the new direction, it is then 139 miles from its point of departure. Describe the bearing from point B to point C. Okay, so I need to find that angle B in there before I can find the bearing. So cosine of B, this is one of the rearranged equations. It's 80 squared plus 60 squared minus 139 squared divided by 2 times 80 times 60. Take the inverse cosine of all that, and my angle B is 166.15 degrees. And to figure out the bearing, because this is messy, hold on. To figure out the bearing, remember it's always off of one of the, there we go. It's always off of one of like north or south. So what I want to do is figure out what this angle theta is, because that will be north theta east. So to figure out what my theta is, I can subtract 90 degrees from my angle that I just found. And my bearing will be north 76.15 degrees east. Okay, so we don't want to just leave it as 166.15. We want to describe our bearing off of north or south. Next we have an area formula. Given any triangle with 3 side lengths, A, B, and C, the area of the triangle is given by square root of s times s minus a times s minus b times s minus c. First we need to know what s is. It's all 3 side lengths added together, divided by 2. Okay, so it's not the average, you're not going to divide by 3. It's all 3 sides added together, divided by 2. So when we have an example like we do here, where we have 3 sides, first we want to find s. So we want to add our 3 sides together, divide by 2, s is 84. So to follow our equation then, our area is square root of 84 times 84 minus 43 times 84 minus 53 times 84 minus 72, which is about 1,131.89 meters squared. And down on below, I talk about all of the different area formulas for a triangle. Standard is one we know with a right angle, 1/2 base times height. An oblique triangle where we have 2 sides and the angle that does not match the 2 sides is 1/2 the 2 sides times the sine of that angle. And when we have 3 sides, we just did an example of that where we find s. All right, well, that was section 6.2 on law of cosines.